Assalamualaikum. So my name is Muhammad Amirul Rahman. This is my group mate. We are from subject IDP project. So my group mate, can you please introduce yourself?
Hello, my name is Sharmuga Prasan, son of Nagar Islam. My matrix number is 194904. Followed with
Hello, my name is Baozhenfei and my matrix number is 191334.
Hello, my name is Aifni binti Gozi and my matric number is 193481.
Hello everyone, my name is Muhammad Al-Mursi. My matric number is 195077.
About our IDP subject, we were assigned to do a project which is renewable energy. So we have formed a company to encounter the problem about the renewable energy. So without further ado, we will present the slide of the work that we have done.
So we are the group for this project. I will presentation about the introduction. So my friends and will presentation another part. So next. For introduction, photovoltaic system consists of one or more solar panels coupled with an inverter and other electric and mechanical equipment to produce electric using energy from the sun. From small rooftop or portable system to large utility-scale generating plants, photovoltaic system can be very great in size. And solar photovoltaic system is a new type of power generation system which uses photovoltaic effect of solar cell semiconductor materials to convert solar radiation energy into electric energy directly. It has two models of off-grid and grid contact operation. Its principle is from the electric energy inside the solar panels through the accretion of sunlight and then transfer the electric energy by the solar cell into the battery through the charge and the discharge controller. And next.
Okay, for the problem statement, Teraci Agriculture Resources, which is located in Temoh, Perak, has been established for 1.5 years. Their business consists of durian seedling and also contract farming. After interviewing one of the workers there, the plantation has the size of 5.5 acres and they are planning to expand their plantation to 20 acres. He stated that the main issue that the company face is the power supply for constant irrigation. Currently, they are using a water sprinkler system as their irrigation and it runs at 30 psi. However, they noticed a difference in pressure as the pressure was drastically decreased to only 20 psi. Their current solution where they inserted water pump causes increase in labor cost and also energy inefficient. They need to drag the pipe to the water source through the jungle where it is 2.5 meters deep. They rely mainly on the pressure from the gravity and it's not sufficient enough to irrigate all the crops efficiently. The workers also need to go to the jungle to the water pump 4 times a day in a week. Moreover, they need to stay there for at least half an hour in order for them to close and open the valve. Therefore, the team members need to design a photovoltaic system that is sufficient enough to provide constant irrigation cost and also energy efficient. Okay, that is all from me.
So next, right now we are going to talk simplifying components. We are going to make it as simple. So what we have here is what the components that we need is like solar panel, and then we are going to use the inverter and the charge controller, which it will control the water pump motor, and it can also control the solar battery that we are going to use it as a backup battery. And then we have the combiner, also we'll use it so we can also control the whole system together. Next, the methodology.
For the methodology, as we can see, the first one is to determine the targeted people. This is where the teammates will find the targeted people that face power supply problems or people who we want to find alternative ways to gain power supply efficiently in order to find a solution to mitigate their problems by using PV system, aside from reducing pollution in Malaysia. The second one is interview and analyze the problem. Interviewing is vital in order to help the team members to understand the clients better and also explore their opinions. The third one is the calculation. Since the main problem is the water pump, the energy imparted to the water by the pump and the power consumption for pumping water needs to be calculated. The formula will be shown at within the next slide. The fourth one is also the designing and analyzing. The design will be created using MATLAB software since it has multiple functions. The result of the design may not be exactly the same due to some factors that are taken into consideration. The result will be then compared to the theoretical answer. And the fifth one is the solar panel selection and installation. After designing the PV circuit, the team members need to choose the solar panel where the cost must be within the budget estimated by the client. It needs to be a good quality system and also durable in order to prolong the solar panel's lifespan. And also other consideration needs to be taken.
So right now we are going to talk about the cost that we have here. We have in total 7 equipment that we are going to use. The first one is the GSM 596 solar panel. It has the 1956 multiplied by 1310 multiplied by 45 mm for the cell. It produces a 500 watt and it's called temperate glass solar panel. This one is very rare to find, but actually it's very advanced. It's very new. This is the first 500 watt glass that it's been in the market. The second one is the CR 500 watt hybrid inverter, 12 volt input, and the output is 220 volt output with built-in 10 ampere solar charge controller. The next one is the solar panel UPS backup battery, which is 12 volt, and it has 100 Ah battery matrix, rechargeable, sealed, and lead acid. Next is the eco-worthy 400 strain DV combiner box with lightning arrest with a 10 ampere rated current fuse circuit breakers for on and off grid solar panel system. Then we have YW 6 ampere MPPT solar panel regulator battery solar charger controller, which it will help us to control the solar panel. Then we have the motor, the water pump that we are going to use to pump the water to the tanks. These are as we are going to show after this, the whole system will going to use 0.1 HP, but actually the least HP, the least horsepower in the market, it's 0.5 HP. So this is the only, this is the least HP that we are going to use. Second, after that, the 100 meter length sharing 4 mm square electric cable, PVC cable. This kind of cable we are going to use. It has a maximum ampere of 10 ampere, maximum current of 10 ampere. This one is we are going to use it in the whole system, as the maximum current that we are going to have in the whole system is 10 ampere. So as we said before, the total cost and equipment, we said before that we have 7 equipment, and it will cost us 4,180 ringgit. We did a comparison between different watts of solar panel to see whether if it's better to use just one panel or use several panels. So we said that we need a 500 watt output. So let's say we have a 2 solar panel of 250 watt. It will cost us 900 ringgit. The dimension is it has a big area. The efficiency is good, no problem. If we use four solar panel, it will cost us 1,600 ringgit, and it will it will make the area very busy because it will have a big area. The efficiency is also good, no problem. But with the 500 watt solar panel, when we are going to use just one, it will cost us 700 ringgit, and it will has a small area. There will be no problem with the area, and the efficiency is good and stable, and it's not affected so much as because like when it's there is a big area, there is a lot of functions, there is a lot of factors that it can affect the whole system. So next.
So today I would like to present about our design. So this is the targeted farm that place in Ummo. This overall place is 5 acres, and this is our plan to. This is our site to design the project by our client. So initially he said he just want to give us 5 acres. He want to see how we work. Then only he will have a budget for all other 20 acres watering system. So let's move on to the EPANET. So based on the 5 acre, I plan to do a EPANET software. Actually, EPANET software is an application. It's a worldwide application to model water distribution system. So from here, this is the simulation that I have done. So this is the reservoir, and this is the main junction, and this is the motor pump that we are going to use, and also this is the storage tank, and this 4 knot. This 5 knot is called as a junction. This junction is placed for each acre. Means this junction is for 1 acre, this for 1 acre, and each and every 5 junction is called 1 acre. So totally we have 5 acres. So now we have 5 junctions. So the main reason why I choose EPANET to run the simulation is it's easy, and also it's easily can operate. That's why I choose EPANET software. So this EPANET software also, when I just obey all the rules from Suruhan Jaya Perkhidmatan Air Negara PAN. And so let's move on to the AutoCAD design. So based on this picture, I want to merge the EPANET with this picture, but unfortunately I cannot do that. So I just designed in the AutoCAD about that. So this is the design I done it in AutoCAD, and this is the motor, and this motor is connected to a solar panel, which is later will explain by Amrul Rahman. And this is the main, as I said, this is the EPANET structure, and also this is the structure of the site, the agriculture land. So let's move on to the. Before move on, I just want to explain about the tank. The reason why we put the storage tank at the mountain area, because we want to distribute the water in the gravity flow. So if we want to put the storage tank in the mountain area, then only we can supply the water to each acre by gravity flow. So let's move on to the this is the PDF form. This is the PDF form converted the design. And let's move on to the water demand calculation and tank size assumption. So basically, I just simply take a 1 square meter, taking 100 ml of water per second. Then I convert it into minute, and in 1 acre, 4,047 meter cube, and 5 acre 20,000 meter cube. So I calculate for liter demand for each minute and also hour. After I calculate, then I calculate for half day. The reason why I calculate for half days, if we construct a storage tank, there is always should be a minimum amount of water, which is called as safety water, which will be stored in the storage tank for the safety purpose. Let's say there is no water supply, then the storage tank will have water. That's why I choose a half day calculation. And the total meter cube for half day is 87,415, and we just use tank volume is 50,000 meter cube, because 50,000 meter cube also already big, and also the balance, the 37,415.2 meter cube is from rain harvesting. Basically, agriculture will be use a lot of water, so in the small portion we have to do the rain harvesting also, in order us to get the approximate to 87,450.2 meter cube, so half day. So even though we calculate the tank volume, the daily requirement that we use is we just use water for around 1 hour or 2 hours. So 1 hour it requires 7,284 meter cube only. So if let's say we calculate for 2 hours we are using water in one day, in one time. Actually, agriculture have to use water 2 times, and we are using 1 day water is around 14,569.2 meter cube for 2 hours. So we assume that we are using the water for 2 hours. That's why I just put it 50,000 meter cube. So we don't we have lack of water. So let's move on to the calculation. This is the horsepower calculation. So based on the formula we use, the height of the mountain is, we say that, as our client say that it's around 8 meters. So we converted into feet, and then I get around 0.1 horsepower. But as Elmosi said that the minimum horsepower also 0.5, so we just applicable with 0.5 horsepower water liter. And the time taken, we also calculate the time taken for fill up the tank. So it's around 58.9, which is around 2.5 days ready. So which means the first time we trying to fill up the tank means we have to wait for 3 days. After that we will always have the water to give a supply to all the plants. So let's move on to the last calculation, which is power consumption calculation. So based on the formula we obtain, based on the formula we use, we get 462 watt, means 0.4624 kilowatt per hour only we will get. So by using 500 watt solar panel, we can encounter this problem. So let's move on to the next part, simulation, which is done by Aminur Rahman.
So my part is simulation. So next slide please. So my part is doing simulation for the photovoltaic panel configuration, and based on the specification given. So as you can see, our group member Shanmuga has calculated and given some parameters for our reference for our simulation. So by using the numbers that we get from the calculation, we have formed some simulation respect to our client specification. So as you can see on the screen is the PV array configuration, which means the specification that the photovoltaic array have. So in this simulation, we have used one series of modules times with 5 parallel string, which is suitable for our power range that needed to be generated. So as you can see here, this is the graph of current with respect to voltage. As you can see for the first one, you can understand about the graph itself, which peak around 30 volt. So this is the configuration, and for the power configuration, power respect to voltage, you can see the power it also peak at 30 volt. So and the max power at the maximum configuration is 1000 watt. So that's the thing, which is the important parameter, which is our photovoltaic panel that we use. So for the next slide. So this is our diagram for the photovoltaic. For your information, we use the boost converter to act as a charge controller in photovoltaic, which is a main component. So as you can see here, at the PV panel, you can see the value of irradiance and temperature, which is remain constant. So this is a constant that have been received by the PV panel. So in order to construct a photovoltaic system or power system, we need a power GUI, as you can see here, and the value is set to 0.5 ampere as a discrete. So in this PV system, we are connected to some set of charge controller with no batteries, because in MATLAB there is no rechargeable battery. So as you can see, this is off-grid and direct photovoltaic system. You can see here from the start, the PV panel will receive the irradiance and temperature and will directly into the impedance, which is C boost converter, which is act as a charge controller. Then at last, it is connected to a load for our reference. So the load then connected to the scope to enable us to see the power output that generated by our system. So in this scope, also we have input and output, input current and input voltage to the scope. So next slide, please. So as you can see here, this is our result. The graph is quite small, but you can see that the voltage produced against time is 38 volt, while the output current is 3.7 ampere, will result the output of 140 watt, which is tally for the calculation that Shanmuga have done. So here is the input voltage and output voltage, as you can see, IPV and VPP. So we have 5 configuration, which is power, output voltage, output current, input voltage, and input current. So the product we have, the product for the voltage, output voltage and output current is 140 watt, which result as the power. So the power generated by our system is enough to encounter the PV system that we have designed.
Okay, this is, as you can see here, this is our brochure. In this brochure, we have who we are, which is our energy Sdn Bhd, and that is also our background. And we also have our product, our product will be supplied according to the client's choices of solar brand. As you can see there are like several types. And we also have the testimony, and also it shows the feedback from 2 of our customers. And that's all in the brochure. It's simple. So if you are interested, please do contact us, which is provided in the brochure. Thank you.
In conclusion, we have achieved the objective of this project, which is to set up renewable energy in a rural area. So as you can see in the introduction, we have achieved our objective, which is we set up a photovoltaic system, which is renewable energy in Timur Perak, which is rural area in agriculture business. So when there is a demand for power, and there is the chance for we to supply. So I think it's a good point for our business operation to supply the PV system in agriculture sector, because nowadays modernized agriculture has spread widely in Malaysia. So I think that's all from us. Thank you.